Hello everyone, my name is Muhammed Muath. Me and my friends Obaid and Ahmed will be introducing you to Page Replacement Algorithms, a comparative performance study. Now, before we start, I want to briefly explain why this topic is actually important. Like every model operating system relies on virtual memory, and whenever physical RAM becomes full, the system must decide which page to remove and which one to load. That decision directly affects performance, speed, and overall user experience. So, in our presentation, we will look at how page replacement algorithms work, why we need them, and how different algorithms compare in real-life scenarios. Understanding these concepts helps us appreciate what happens behind the scenes when a computer manages memory efficiently. Now I'll begin by introducing the background of virtual memory, page faults, and why replacement algorithms are necessary. After that, we will move through FIFO, OBT, LRU, and the clock algorithm, along with a comparison of their strengths and weaknesses. Now before I move on, let's find out what does FIFO, OBT, and LRU stands for. So for the first one, the FIFO, it stands for first in first out algorithm, and for the OBT it stands for optimal algorithms, and for the LRU stands for least recently used algorithms. But I'll not be talking about them in details now, but my friend Ahmed, he will be talking about them in details in the next slides. But now I'll be talking about virtual memory overview. Now the virtual memory lets a computer pretend it has more RAM than it actually does. Each program gets its own large virtual memory, virtual space, while the operating system decides which parts stay in real memory. This makes multitasking easier and keeps program running smoothly even when physical memory is limited. Next, we have the page fault handling steps. A page fault happens when a program tries to use a page that isn't currently in RAM. When this occurs, the OS steps in and does the following. And here we have 6 steps. The first step, it checks the request to make sure the program is allowed to access that page in the first place. Then, it finds space in memory, either an empty frame or a page to replace. Then, it saves the old page if it was modified. Then it loads the needed page from disk into memory. Then it updates the page table so the system knows where the page is. And lastly, it resumes the program right where it left off. Now, for my last section here, I'll be talking about locality and working set model. Now, programs don't access memory randomly. They tend to follow certain patterns, and here I'll be talking about 2 certain patterns that are very common in operating systems, and they are used in the operating system pretty much. So here we have 2 certain patterns that I'll be talking about. The first one is the temporal locality, and the second one is the spatial locality. The temporal locality means that if a page was used recently, the program will probably use it again soon. And the spatial locality means that when a program accesses one memory address, it's likely to use a nearby addresses next. Now, because of these behaviors, each program has a working set, which is the set of pages it actively needs at a given moment. If this working set fits in memory, the program runs efficiently, but if it doesn't, the system starts swapping pages constantly, which leads to major slowdowns. Now, that's the end of my section. I'll leave the rest to my friend Ahmed to let you walk through the 4 main page replacement algorithms.
Hello, my name is Ahmed, and I will continue explaining the page replacement methods, starting with first in, first out. The idea of first in, first out method is super simple. It's a page replacement method that removes the page that's been in memory the longest. Think of it like a line. The first page that comes in is the first page that goes out. It's very easy to understand, very easy to implement, but it doesn't care how useful a page is. If it is the oldest, it gets removed. Next is the optimal page replacement algorithm, or simply OPT. OPT is the perfect word algorithm. It gives the best possible performance. It looks ahead at future memory requests and removes the page that will not be used for the longest time. Basically, if you knew the future, you do make perfect decisions. And that's exactly how OPT does. Of course, these systems can't predict the future, so OPT is only used for comparing other algorithms, not in actual operating systems. Next is least recently used, which is much more realistic. Least recently used removes the page that hasn't been used for the longest time. Basically, the page the program forget about. It assumes a very natural behavior of programs. If you used a page recently, you will probably use it again. If you haven't used it in a long time, maybe you won't use it soon. It's very smart, but tracking the exact order of usage can be expensive. Finally, we have the clock algorithm, which is basically a simplified, efficient, and practical version of least recently used. Pages are arranged in a circle, like a clock. Each page has a reference bit. A clock hand moves around the circle checking pages. If a page was used recently, it gets a second chance. If it is not, it gets replaced. So why it is good? Because it is fast, simple, and good enough for real operating systems.
Hello everyone, my name is Obaid. Let's continue our presentation. Let's talk about comparison summary. Let's talk about the first one is FIFO. FIFO is simple to use but usually gives a poor result. The second one is OBT. OBT is the best in the theory but impossible to use in real life. The third one is LRU. LRU makes smart choice but is costly to track. The fourth one is clock. Clock is fast and gives a good result with less overheads. Each algorithm has its own strengths and weaknesses. Here we have a modern operating system. Modern operating system usually makes a different idea to get a better result. Here we have three: Linux, Windows, Mac. Let's start with Linux. Linux use structure similar to LRU. The second one is Windows. Windows adjust to working set size for each program. The third one is Mac. Mac save space by compressing pages. All of them try to keep the most useful page in memory. In conclusions, all four algorithms helps to operating system decided which pages to keep and which ones to replace. FIFO is the simplest method. OBT shows the idea case. LRU follows real program behavior, and clock delivers a fast and particular solutions. Together, these algorithms shows how operating system try to stay smooth, fast, and efficient, even when memory is limited. Here we can see all our references, and that's it. Thank you for listening. Have a good day.